Hey everyone, so let's check out this question that was submitted to us here. It says prove each identity that 1 over sine squared theta plus 1 over cosine squared theta equals the tan of theta plus 1 over tan theta squared. Alright, so let's go ahead and try to prove this here. So first thing I'm going to do is I'm going to do out this right hand side and show that when you have something squared, it means that it's multiplied by itself. So we're going to take this and times itself here, tan theta plus 1 over tan theta. And we're going to distribute this through. Some of you people call this FOIL. So tan times tan gives us tan squared theta. Tan theta times 1 over tan theta actually means that the tans are going to cancel out there or reduce down to 1, I should say, plus 1. And then 1 over tan theta times tan theta will also become 1 again. And then 1 over theta times 1 over theta simply becomes 1 squared, which is 1, over tan squared theta in this case. Okay, so we have this, which is the same thing as saying tan squared theta plus 2 plus 1 over tan squared theta. Okay. I'm just going to stop here for a second, and I'm going to do the left-hand side out. I'm going to simplify this down by getting a common denominator here. In this case, the common denominator is going to be sine squared theta times cosine squared theta. So in order to do this, I need to multiply this left-hand side by cosine squared theta on top and bottom, and the right-hand side I need to be multiplied by sine squared theta. So we'll end up with cosine squared theta times 1 is simply just cosine squared theta, plus, over here, 1 times sine squared theta is sine squared theta, and that's all over our common denominator now, which is cosine squared theta times sine squared theta. Okay. So we still want to show that these two are equal. Well, there's an identity that says cosine squared theta plus sine squared theta is equal to 1. So we're going to go ahead and let that be 1 here. So this whole top part becomes 1. And then on bottom we have cosine squared theta, sine squared theta. And I think I'm going to leave that alone and go back to the right hand side here. So let's do some work with this now. I'm going to go ahead and change everything into sine and cosine. So tan is the same thing as saying sine squared theta over cosine squared theta here. Okay, that's what this becomes. I'm going to bring down the plus 2, and then 1 over tan squared theta is actually the same thing as saying cotan squared theta, and cotan is the same thing as cosine squared theta over sine squared theta. Alright, so now we have this here. So I'm going to continue going farther here. I'm actually going to now combine the right hand side in blue here together by getting the like term again. But again, like denominators. So here, my like denominator is going to be cosine squared times sine squared again. So I'm simply going to go ahead and multiply this by sine squared theta on top and bottom. This needs to be multiplied by cosine squared theta and sine squared theta. So this has to be multiplied by cosine squared theta and sine squared theta. And then this one needs to be multiplied by cosine squared theta. Okay, so sine squared times sine squared is going to become sine to the 4th theta. Then we have 2 cosine squared theta, sine squared theta. And then on the right here we have cosine to the 4th theta. So that's all over cosine squared theta, sine squared theta. Now that top part there can actually be factored. You could think of this as kind of that factoring method called AM, where you're looking for two things that add to this number and multiply to that number out here. In this case, what this is going to become is sine squared theta plus cosine squared theta times sine squared theta plus cosine squared theta. Because if we do this out, sine squared times sine squared gives us sine to the 4th. sine squared times cosine squared is 1 cosine sine, or 1, cosine squared sine squared. Cosine squared times sine is another 1 cosine squared sine squared. That's how we get the 2 cosine squared sine squared up here. And then cosine squared times cosine squared gives us the cosine to the 4th. Now in this case here, and that's still going to be all over our cosine squared theta, sine squared theta. Well, once we get down to this step, sine squared theta plus cosine squared theta is the same thing as saying 1. So this whole thing right here becomes 1. Same thing with this side. Sine squared plus cosine is the same thing as 1. And 1 times 1 is simply 1. So we end up with 1 over cosine squared theta, sine squared theta. And you can see that equals 1 over cosine squared theta, sine squared theta. So now you've shown that the left-hand side equals the right-hand side, so you've proved that this identity is true.